So welcome back to the channel, guys. Hope you are doing extremely well, and in this video we are going to discuss the question single element in a sorted array, which is lead code question number 540, right? So what does the question say? The question says that you have been given a sorted array, right? And in this array all the elements occur twice. All the elements occur exactly twice, but there is an exception. There is one element which occurs only single time, occurs only single time which occurs only single time. Okay, now the problem says that I have to find that single element. I have to find that single element and report it as my answer. For the given case, the question is 1 1 2 3 3 4 4 8 and 8. So it is easy to see that 1 1 is actually occurring in pair, 3 3 is also occurring in pair, 4 4 is occurring in pair, 8 8 is occurring in pair, but 2 doesn't have a pairing element. So 2 is my answer here. 2 is my answer here. The note in the question says that your solution must run in O of log n time and O of 1 space. O of log n time and O of 1 space. But first let us see what is the approach. What is the brute force approach if this note was not given? So the brute force approach will be simple. I will do the linear search. I will do the linear search. I will do the linear search. And now, because the array is sorted, I know that if 1 is here and and the next element is not 1, that means 1 is my single element. But here 1 is pairing up with another one. Now, if I go to 2, I see another 2 is not present in the next position. That means 2 is my answer. So I can break my loop here, right? I can break my loop here. So my linear search will look something like this. I will not say it is exactly linear search. I will say it is optimized linear search. Optimize linear search. What I will do is I will say for I equals to 0 up till n minus 1, what will happen if my I equals to n minus 1, that is I have reached the last node. I have reached the last node and I've still not found a single element. That means this element has to be single, right? Because all of the previous ones have been paired. So if I equals to n minus 1, in that case return array of I. Otherwise, if it is not the case, that means if a of I is not equals to a of I plus 1, that means I have found my element. I will simply return a of I, right? Else I will move my I up by 2 pointers, because if this is pairing up with this, I can simply go to 2. I plus equals to 2. I plus equals to 2, right? Okay, so this is my case for linear search, and this is running O of n by 2 times, because I'm incrementing by 2, so it is getting n by 2, but that is essentially big O of n only, right? I can treat it as big O of n. But the question demands us to use O of log n complexity. Now, I would like to bring to the notice three factors. What is it? I have to find, first of all, the factor is find. Second factor is sorted array. And third factor, which is not given all the time, but still here it is a beneficial factor for you, O of log n time. Whenever you find above two factors, third factor is just cherry on the top. Above two factors give you an indication that you have to do a binary search. And the third factor in this question is actually providing you the concrete proof that binary search will be your approach, right? Binary search. Now, how will you use binary search is up to you. How will you use binary search is your technique. So the array given to me was 1 1 2 double 3 double 4 double 8, right? Let me mark the indexes. So index will be 0 1 2 3 4 5 6 7 8. For the first, let us conclude that there are, let's suppose there are n elements in the total array. Size of the array is n. Can I say that n is always odd? N is always odd. What is the basis? I am saying that all the elements are occurring twice. That is, I can say it is of the form 2k. N is of the form 2k. But one element is not occurring twice. It is occurring only once. So 2k minus 1. And 2k minus 1 will always be odd. That is my first proof. That is my first conclusion. And because n is odd, n minus 1 will have to be even. N minus 1 will have to be even. Okay. Moving on. Now binary search simply says I have to move my low pointer here, I will have to move my I pointer here, and the basic template of binary search says while low is less than equals to high, find a mid. Your mid will be low plus high by 2, right? So here my low is at 0, my high is at 8, that means my mid will be at 4. My mid will be at 4. I will place my mid here at 3. I will place my mid here at 3, right? I have placed my mid here at 3. Now you can see that mid is here, right? But is 3 my answer? No, 3 is not an answer. Binary search works on the principle that I have to remove one half. I have to remove one half. That can be left half or the right half. And which half I have to remove will be determined by some properties, right? Which will be determined by some action, some implementation I need to do. Now, how can I choose whether to deduce this half or this half? My answer lies here. I know from the fact that my answer lies here. I have to reduce right half. But how? What will be the condition I will be using to remove the right half? So I have found 3. Can I say if I see that if 3, that is array of mid, doesn't have a pair, does not have a pair. If array of mid does not have a pair, I can simply say your answer is array of mid. That means if array of mid, that is 3, is occurring only once, I can simply say return a mid. That is my first condition, right? If array of mid does not have a pair. Now how will I calculate pair? Because the array is sorted, my pairing element will be present just before it or just after it. It can be present here or it can be present here. In this case, this is true. In this case, 3 is true. So I will make a condition. Let me make it again. So we know we have to find a pairing element which can be present on the left side or on the right side. Now, to avoid the segmentation fault, see, my mid can be present on the n-1th position or on the 0 position. So I will check that cases first. So I will say if mid equals to 0, that means my mid is on the 0. Then if the pairing element is present, it can only be present at 1. So I will say if array of mid plus 1, because 0, so mid plus 1 is 1, is not equals to array of mid. In this case, this is an nested if. In this case, I can simply return mid plus, I can simply run array of mid, because this element present at 0 will not have a will not have a pairing element. That means it is occurring single, right? If this condition is not true, if the nested if is not true, that means these these two elements are pairing. That means my answer lies in this remaining part. That is, if this is low, this will be low plus 1, this will be low plus 2. That means my answer lies in low plus 2 up till high. If this nested if is failing, that means I will say else my low changes to low plus 2, right? My low changes to low plus 2, right? My low changes to mid plus 2, sorry, mid plus 2, right? My mid plus 2, because my mid is here, right? Moving on, same condition lies here. If my mid is equals to n-1, so I will say if my mid equals to n-1, what will I do in this case? I will check the previous element, because that can be only the pairing element. So if my mid minus 1 is not equals to my mid, in that case return array of mid, else change your high. Now because if these two are pairing, my high will change to, my mid is here, my high will change to mid minus 1, mid minus 2. I will find my answer in these intervals. So my high will change to mid minus 2, right? Moving on, if these are not the cases, that means my mid is present between 1 up till n-2. Now I can simply say that I have to use the pairing property between 1 with the previous or the next element, or the predecessor or the successor. So first case, if my array of mid is equals to my array of mid minus 1. If my array of mid is equals to array of mid minus 1, which is the case here, that means 3 is equals to 3. Now the feature I will be playing at, if this is equals to this, that is this mid is equals to its predecessor, that means this is a pair. Now I know that the elements left in the left half will be 1, 1, 2. I have found this pair, that means element present in the left half are 1, 1, 2. Elements present in the right half are 4, 4, 8, 8. That means 4 elements are present here, 3 elements are present here. And that can be easily calculated. If this is equals to this, 3 will be calculated by mid minus low, that is 4 minus 0 minus 1. It will give me 3. And similarly, 4 can be easily obtained by high minus mid. Right? This will be right half. But this is for the condition why mid is equals to mid minus 1. Okay. Now, moving on. If this half contains 3 elements, if this half contains 3 elements, isn't it sure that my answer will be present here only? If this half contains 3 elements, see, if the length is odd in a half, then my answer contains that, because all other are occurring in pairs. So for example, if this is 4, that means elements here are forming 2 pairs, because 4 divided by 2 is 2. So one pair, second pair. But 3 is not divisible by 2. That means odd. That means one element has to occur single. One element has to occur single. So I will say my high will move. Where will my high move? Because I have ruled out this interval, my high will move to mid minus 2. High will move to mid minus 2. I will use that condition to write if array of mid equals to array of mid minus 1. My right elements would be high minus mid. My left elements would be mid minus low minus 1. Mid minus low minus 1. Now if my right percentile 2 equals to 0, in that case elements on the right are occurring in pairs. In that case, I will say I will move my high towards mid minus 2. If that is not the case, suppose here 4 elements were present and here 3 elements were present, that means I will have to move my low towards this position. In that case, I will move my low towards mid plus 1. My low will become my mid plus 1. Else, low equals to mid plus 1. So this was the case for if my mid is equals to its predecessor. But moving on, I can also find the element on the successor. So if my a of mid equals to my a of mid plus 1, equals to my a of mid plus 1, what will happen then? So I have to revert this case, that is mid is here. Suppose mid is here and my mid plus 1 will be here. In this case, again I will find the left elements, again I will find the right elements. What are the left elements now? My left elements will be mid, that is there are 3, 1, 2, 3, right? Mid 3 elements are there. So I will say 1, 2, 3, that is mid minus low, right? These are the elements on the left. And what are the elements on the right? So it will be 1, 2, 3, 4, right? 4, 4, 8, 8. That will be high minus mid, that is 8 minus 3, this is 5 minus 1, high minus mid minus 1. Now I will see if this is odd or this is odd and accordingly act to the condition. So now if first I will compute, so my right is equals to high minus mid minus 1, and similarly my left is equals to my mid minus low. Now if my right percentile 2 equals to 0, that means my right contains even number of elements, as is this case. So in that case I will have to decrement my high. Now because my mid is here, I will have to decrement high here, that is my high will become mid minus 1. My high will become mid minus 1, high equals to mid minus 1. Else my low will change to mid plus 2. Why plus 2? Because I have already explored this element, and because this element is getting paired, this element is also explored, and this is mid plus 1, this is mid plus 2. I will drop my low here. My low will change to mid plus 2. My low will change to mid plus 2. Now a case can be that this is also not true, this is also not true. That means the element does not contain its pair. That means else I will say return a of mid, because it is the single element, right? Okay, so this is the case, and let us try to code it down. Let us try to first visualize the dry run, right? Okay. Alright, so here is the dry run, guys. So my low is equals to 0 in the initial and my high is equals to 8, that is n minus 1. Firstly, 0 plus 8 by 2 gives me 4. That means mid is here now. I will check for the 0 and n minus 1 condition, that is not occurring. Mid is equals to is mid minus 1, right? So I will see right and left. Let me make the columns for right and left also. So right contains 4 elements now and left contains 3 elements. Right contains 4 elements, left contains 3 elements. This is odd, left is odd, that means my high will move to 2. My high will move to 2. my low will remain 0. Now 0 plus 2 divided by 2 gives me 1. My mid will come here. Now the elements between this, because my high is here and low is here, elements, first I will take the condition 1 is equals to its predecessor. So again I will check for the low elements and for the high elements. My low elements will come out to be 0, left is 0 and right is 1. Right is 1. So because right is 1, I will move my low to mid plus 1, that is 2. My high is already a 2 and 2 plus 2 divided by 2 gives me 2. But 2 does not contain any predecessor or successor as the same. So 2 is my answer. I will return 2 safely. Okay, so I hope the dry run is clear to you. Now let us move towards the code. So here we are. First, I would like to request you to please subscribe to the channel if you have already not subscribed to my channel, and stay tuned for the more amazing content I will bring out to you. Now, first I will say my int10 equals to nums dot size. I will include a base case that if my n is equals to 1, that means only one element, I can simply, without any procedure, I will say return nums 0. Alright. Now moving on. Now I will define my low as 0, my high as n minus 1, while my low is less than equals to my high. My low is less than equals to my high. So I will say, I will make my mid is equals to low plus high by 2. First condition is to check for mid is equals to 0. In that case, the nested if will be if mid is equals to 0 and if nums of mid is not equals to nums of mid plus 1. In that case, I will return nums of mid. I will return nums of mid. Else, I will change my low. My low will change to mid plus 1. Low will change to mid plus 2, sorry. Low will change to mid plus 2 because I have to skip the pair element. Else, if my mid is equals to n minus 1, that is the last element, I will check for the predecessor same. So, nums of mid is not equals to nums of mid minus 1. In that case, return nums of mid, and if that is not the case, change your high to mid minus 2, right? Now, else if, that is we are in the main part, that is from 1 to n minus 2, nums of mid is equals to nums of mid plus 1, that is successor is equal. In that case, my elements on the right would be high minus mid minus 1 and left would be mid minus low. Now, if my right percentile 2 is equal to 0, that means right elements are even in number. That means I will have to shift my high. My high will become my mid minus 1, and that is not, if that is not the case, I will say my low changes to mid plus 2. Similarly, for the case if nums of mid is equals to nums of mid plus 1, in that case, firstly compute your right and left. So my right in that case would be here, it will be a square bracket and this will get deleted. If in that case, right will be high minus mid and left would be mid minus low minus 1. Again, if my right contains even number of elements, right percentile 2 equals to 0, in that case again change your high, but your high will change to high equals to mid minus 1 now. Sorry, high is equals, this will be mid minus 1, sorry guys, this will be mid minus 1 and this will be changed to minus 2, else change your low to mid plus 1, right? And all the above cases are not true, that means the element does not pair with anyone, else return your nums of mid because that is a single element you are looking for. For the safety cases, after this while loop, you can easily say return minus 1 if that element is not paired in the array, if all the elements are paired up, right? Let us try to compile and run it now. Hope it will work. In the meantime, please, oh, there has been some error. I have not declared lower right. It is equals to 0, right? Let us try to compile and run it now. Hope it will work. In the meantime, please consider subscribing to my channel and hit the like button as much as possible. Returning for the sample test cases, let's try it out for the submit button as well. Taking little time. It is getting submitted exactly fine. Okay, thank you for watching. Have a nice day and we'll meet tomorrow with a new video. Until then, stay tuned. Have a nice day.